Empirical knowledge in software engineering has two main sources. First, we can measure things, or we can ask experts. That is, we utilize expertise, find out what they think is true. Okay, let's have a look at examples of both measurement and expertise. As an example of measurement, a study of exploratory testing was done, and it found that exploratory testing and test case-based testing both detect the same number of defects. So here we are talking about objective number that was measured in the experiment. On the side of expertise, a qualitative interview study was made, and it found that according to experts, exploratory testing is more suitable for giving rapid feedback than test case-based testing. This is obviously because if you want to give rapid feedback, and if you want to be rapid, then you probably don't have time to create the test cases first. So therefore, exploratory testing that does not require test cases is more suitable for this rapid feedback type of working. Research methods used to collect these measurements are typically experiments. In an experiment, you set up an artificial setting where you compare two techniques or tools. For example, in the case of exploratory testing, it was compared with test case-based testing. Then students were recruited for the experiment, and they performed testing using both techniques. So, for each technique, we had roughly 60 students trying them out. So in total, over 120 students were part of the experiment. Therefore, the study could conclude that there is no difference in the defect detection capability between exploratory testing and test case-based testing. Mining software repositories is another technique for collect measurement. It does not involve artificial setup like the experiment. Rather, it relies on the repositories that are used in software development. Such repositories can be version control system, defect reporting system, or email communication that is used between the software developers. Therefore, the data, for example, from a defect reporting system can be used to reason whether a particular process change results in smaller number of defects. For example, a few years ago, Mozilla Firefox made a famous change from traditional release cycle that had roughly one yearly release to a rapid release cycle with releases coming out every 6 weeks. This change from traditional release cycle to rapid release cycle created a sort of a natural experiment where something in the process changed. Several research papers have utilized this natural experiment, and they have explored the software repositories to study the number of crashes, the types of testing done, and other factors that have changed when moving from traditional release cycle to rapid release cycle. Problems with these measurements or research methods that result in measurements, such as experiments and mining software repositories, are that the setup, especially for the experiments, is typically artificial. Students are recruited, for example, to perform 2 hours of testing. Some people may argue that this does not correspond to industrial software development, and therefore the results of an experiment cannot be generalized to industrial context. Threats in the mining software repositories approaches is that the story behind the numbers is not always everything. For example, when the change in the Mozilla Firefox from traditional release cycle to rapid release cycle was made, there were several other changes that also took place at the same time. So not all the changes that can be measured from software repositories, such as defect reporting, can be attributed to the change from traditional release cycle to rapid release cycle. Both of these research methods also suffer from the problem of context that I shall explain later. On the other hand, on the expertise sides, where we wish to study the perception of industrial experts, the research methods that are used to collect this expertise are typically either qualitative interviews, where we can ask questions such as, tell us about the benefits and drawbacks of exploratory testing, or we may formulate survey or questionnaire forms to study this perception of experts. For example, we might have questions that exploratory testing is suitable for giving rapid feedback, and then we would provide a scale: I disagree, I agree, and the expert would select the proper option in this questionnaire form, regardless of which method is used. We are in both cases collecting perception of experts from the industry. The good side of these methods is that they are not in an artificial setup, as was the case for experiments, and they can tell the story behind the numbers. However, the problem is that they are threatened by human biases. With human biases, we may think things like people report what they wish to be true as the true. I mean, even the experts in the industry might not have enough knowledge about all their things, so they're relying on their perceptions. And if we look into Wikipedia in the link, we can find a long list of cognitive biases. So this is the Wikipedia page of cognitive biases. We can see that the list of biases is very long, and these biases are part of the problem why the methods relying on industrial expertise might not always be reliable.